Problem number 36 says, prove that if A, B, and C are a Pythagorean triple, then KA, KB, and KC, where K is greater than 0, represent the side lengths of a right triangle. Guys, did you ever hear about this Pythagorean triple term? But what is that supposed to mean? Take a wild guess. What do you think means a Pythagorean triple? Amanda? That's absolutely. It means you have three numbers that will always satisfy Pythagoras' theorem, right? That the square of one of them equals the sum of the squares of the other two. So let's suppose that a squared plus b squared equals c squared. And these are my three numbers that are satisfying the Pythagorean triple. And you know what? We have to show that Ka, Kb, and Kc represent the side lengths of a right triangle. Well, basically that they are also Pythagorean triple, because the Pythagorean triple will represent the side lengths of a right triangle by the converse of the Pythagoras theorem. If you have three numbers that are satisfying this condition here, that the square of one of them is the sum of the squares of the others, there will be the sides of a right triangle. So if we can show that if a squared plus b squared equals c squared, that is given, is true, then ka squared plus kb squared plus kc squared, they will satisfy also the same condition, right? So let's check. What is ka squared, everything squared, right? Plus kb, everything squared. If that will be kc, everything squared, then we're fine. We proved it, right? Is that the case? Well, let's find out. What is ka, everything squared? What is that going to be equal to? Well, it would be k squared times a squared, right? So what I have k squared a squared plus kb, everything squared, will be k squared b squared. Kc, everything squared, will be k squared c squared. So what do you guys notice here? I have k squared all over, right? I can actually factor out k squared from the left side, or I can divide right away by k squared the whole expression, right? So I should divide this one by k squared. What's happening here? K squared a squared divided by k squared will go away, right? So you have what? I have a squared plus b squared equals c squared. So what can you tell me about this statement here? Is that true? Absolutely. And we're done. Ka, Kb, and Kc are a Pythagorean triple. That's problem number 36. And we're done.